Good morning, students. So today's class we are going to solve the 5-mark problems in normal distribution, right? So I'm going to start the 5-mark questions from normal distribution. So as I mentioned earlier, as I have told you earlier, you have to carry tables, the normal tables. So these are the normal tables. So you need to carry these tables before just starting the 5-mark problems. Clear? So I hope everybody is having these tables. So let us start now. So question number 1. Heights of PU students. Heights of PU students is normally distributed with mean 155 centimeters and standard deviation 5 centimeters. Find the probability that a randomly selected PU students. Question number 1. Height more than 155 centimeter. Question number 1. Height more than 155 centimeter. And question number 2. Percentage of PU students having height between 150 centimeters and 160 centimeters. So this is the question. Just look at here. Note down the question. Heights of PU students is normally distributed with mean 155 centimeters and standard deviation 5 centimeters. Find the probability that height more than 155 centimeters. And question number 2, the percentage of the PU students between PU students height between 150 and 160 centimeters. So this is a question given. Now first, solution. Here we need to observe the probability of heights of students. So first write down, let x be the heights of students. Let x be the heights of students. Heights of PU students also can be written. Therefore, x follows. Already it is mentioned it is normally distributed. Therefore, x follows normal distribution with the parameters this one, mu comma sigma square. So x follows the normal distribution, mu comma sigma square. Now what is the given information? Mean 155 centimeters and standard deviation is 5 centimeters. So first write down the given information, given data. The mean mu is 155 centimeters and standard deviation sigma is 5 centimeters. So this is the given information. So as I mentioned, capital X, the random variable, follows the normal distribution mu and sigma square. And first write down the standard normal variate form, x minus mu by sigma follows n of 0 comma 1. So you need to write this standard normal variate form, z equals to x minus mu by sigma follows n of 0 comma 1. n of 0 comma 1 is nothing but the standard normal variate. Remember this, where mean mu 0 and standard deviation is 1. Now this is the information. Question number 1, what it is asked? Find the probability that the height more than 155 centimeters. So probability that height more than 155 centimeters. So this is the question asked. Now we need to find out the probability of this one. First and foremost, this x, what it is there given, this has to be converted to standard normal variate. So that means x minus mu by sigma, both the sides, 155 minus mu by sigma. So both the sides you take it as x minus mu by sigma and minus mu by sigma, minus mu by sigma, minus mu by sigma, both the sides we have taken. Now this x minus mu by sigma can be taken as z or no? So take it as z from the taken form of SN greater than 155 minus, what is the value of mu? Mu by what it is, standard deviation 5. So 155 centimeters Now this can be taken as z greater than 155 minus 155, 0. Right? Now draw the normal curve for this. So drawing normal curve is very mandatory one in normal distribution. Now greater than 0 means which side? Towards infinity side, shade that region. So z greater than 0, from 0 to infinity, greater than 0. Now as we have discussed earlier, the total area under the normal curve is always 1. Now from 0 to infinity, what is the area? What is the value? 0.5. So what is this answer? 0.5. So 0.5 is the answer for question number 1. Next, question number 2. What it is asked? Question number 2. We need to calculate the percentage. Before that, we have to observe the height between 150 to 160 centimeters. So let us take probability of height between 150 and 160 centimeters in between. Right? Now, probability of 150 to 160 centimeters. Now, same way, this 150, first we need to convert this x as x minus mu by sigma. The same way both the sides, x minus mu by sigma, 160 minus mu by sigma. So all the three sides we have to balance. Now probability of 150 minus, what is the value of mu? 155 by 5 less than, this can be taken as z less than 160 minus 155 by 5. So convert like this, and then probability of 150 minus 155, so minus 5 by 5 less than z less than 160 minus 155, 5 by 5. So this will be written as minus 1 less than z less than plus 1. By seeing that minus 1 to plus 1, immediately you should be remembering the area property, plus or minus 1. What is the area property? Percentage, plus or minus 1. Draw the curve. So draw the normal curve. So this is minus 1 and this is plus 1. Now this whole region we need to observe, minus infinity, plus infinity, or is it 0? Now from minus 1 to plus 1, this entire region, shaded region should be calculated. Now for that, what we have to write? Probability of area from minus 1 to infinity. From minus 1 to infinity, we have to remove 1 to infinity. The blank region has to be removed from minus 1 to infinity. Always we have the values from negative z or positive z2 towards infinity side. Always z2 plus or minus z2 infinity. We have the tables. Now from that, from minus 1 to infinity, from this area to this area, this is the blank area we have to remove now. So the same thing I have written here. Minus 1 to infinity minus plus 1 to infinity. Now minus 1 to infinity, what is the table value? Just go through page number 429. Minus 1 value, where it is? 0.8413. Minus, and then page number 430. 0.1587. Now the value is 0.687, approximately 68%, because they have asked us in terms of percentages. So the value would be 68%. So this can be taken as 68.26 multiplied by approximately we'll be getting 68%. Now this is the question. Note down. So once again I repeat, look at the question. Heights of PU students is normally distributed with mean 155 and standard deviation 5 centimeters. Find the probability that height more than 155 centimeters and percentage of PU students height between 150 and 160 centimeters. So this is the question asked. See, first the random variable x, let us consider be the number of heights of PU students, and then x follows the normal distribution mu and sigma square, because already it is given that heights of PU students is normally distributed, given data, and mean mu 155 and standard deviation sigma is 5. Now we need to convert this in a standard normal variate form. So z equals to x minus mu by sigma. Look at the question number 1, probability of x greater than 155. Now that x has to be converted to standard normal, right? To convert that x to standard normal, x minus mu by sigma, if you take from the standard normal variate, mu is 0, standard deviation is 1. That means x follows standard normal variate z or no? Automatically. If you substitute mu equals to 0 and sigma equals to 1, x minus mu by sigma remains x. So z equals to x in standard normal variate. So that x to convert to z, I have taken the middle portion, minus mu by sigma, both the sides. Now the probability of z greater than, substitute mu by sigma term, you will be getting 0 by simplifying it. Now the probability of z greater than 0 is nothing but, see there, greater than 0 means from 0 to entire infinity in the shading region. Already you might seen that the total area is 1 from properties of normal distribution. Now in the under the normal curve, the total area is 1. Obviously the half region would be 0.5. So that is question number 1. Now question number 2, probability of lies between 150 and 160. Same way, all the three sides you take it as minus mu by sigma, minus mu by sigma, minus mu by sigma. Simplify the terms. Substitute mu and sigma term, and then you will be getting probability of minus 1 less than z less than 1. So the region from minus 1 to plus 1. Now minus 1 to plus 1, already area property we can say plus or minus 1, the area property would be directly 68%, we can write it. But here we have to prove once again. We cannot write like that by saying area properties. So once again you take that area from -1 to infinity minus 1 to infinity. So here you can ask one question. What is that? Sir, already from -1 to +1, -1 to 0 and 0 to +1, if you add together also the answer will be getting it. No, right, absolutely correct, you will be getting the same answer. But we are following the NCERT government textbook where the normal tables are given plus or minus z to infinity, positive infinity side. If you observe page number 429 and 430, plus or minus 1 to infinity side only we have to observe. That's the reason -1 to infinity, already the value is there. I said minus z to infinity plus z to infinity we have. So here instead of adding together -1 to 0 and 0 to 1, -1 to whole infinity side, if you take the common, I mean empty region would be 1 to infinity. From -1 to infinity total, the 1 to infinity value is the blank region, right, unshaded region. So such region should be removed from the total of -1 to infinity. So and you can see the normal tables, you will be getting the value 0.6826. Question is asked in terms of percentages, so 100 I have multiplied, you will be getting the value 68%. Am I clear? So this is the question. So such a, I mean it seems to be big but very simple one. Minus mu by sigma, always keep that in mind, and you should understand how to shade the region and how to observe the tables, normal tables. So I can show you the normal tables how to observe. See, I said you the previous one, z to infinity, if you observe now z to infinity and then minus z to infinity, these are the values. Minus z to infinity also we have, right? Now minus z to infinity, how to observe minus z to infinity? So here negative values were there, here -1 you check, in that under 0 that value 0.8413, and then from the positive, right, so from the positive 1 to at 1 to infinity, so that is 0.1587. By substituting you will be getting the answer. Clear? So I'll just go to the next question, problem number 2. So problem number 2, x is a normal variate, x is a normal variate with mean 100, with mean 100 and standard deviation 5. Find the probability that, question number 1, x greater than or equal to 105. Question number 2, 90 less than or equal to x less than or equal to 110. So this is the question asked. X is a normal variate with mean 100 and standard deviation 5. Find the probability that x greater than or equal to 105 and 90 less than or equal to x less than or equal to 110. Now already it is mentioned it's a normal variate. X follows the normal distribution mu comma sigma square, and the standard normal variate form x minus mu by sigma follows n of 0 comma 1. Now question number 1, probability of x greater than or equal to 105. Same process, x has to be converted to standard normal variate form. So probability of x minus mu by sigma greater than or equal to 105 minus mu by sigma. Both the sides you take it. Probability of this can be taken as z greater than or equal to 105 minus what is given? Mean. Mu is 100, sigma is 5. Substitute here. 100 by 5. So probability of z greater than or equal to 105 minus 100. 5. 5 by 5. Greater than or equal to 1. Now take the normal curve. Minus infinity to plus infinity. Now 1 is a positive side. Which side it has to be drawn? Here. Plus 1. Now symbol what it is? Greater than or equal to. So this region. So this region we need to calculate. 1 to infinity. Write down. Probability of area from 1 to infinity. Probability area from 1 to infinity. Just look at the tables. 1 to infinity. Page number 430. 1 to infinity. So 0.1587. So therefore the area covered from 1 to infinity is 0.1587. So this is question number 1. Question number 2. What it is asked? Question number 2. Probability of 90 less than or equal to x less than or equal to 110. So probability of 90 minus mu by sigma x minus mu by sigma 110 minus mu by sigma. Therefore probability of 90 minus what is mu? 100 divided by sigma is 5. Z 110 minus 100 divided by 5. So probability of 90 minus 100 is minus 10. One 10 minus 100, 10. Minus 10 by 5 is minus 2. Z plus 2. Now again we have seen this one. Minus 2 to plus 2 area under the normal curve covered region is, again if you go through the properties, area properties of normal distribution, the 95% is covered area. So this can be taken as probability of, before that just draw the normal curve. Normal curve is mandatory. Every problem you have to draw the curve. And here it is minus 2. And here it is plus 2. So we need to shape this region. Now minus 2 to infinity. 2 to infinity if you remove. This area if you remove, you will be getting this area only or not? From this whole region, this region I have removed. So area from minus 2 to infinity minus 2 to infinity. So this value, area from minus 2 to infinity, check the tables. Minus 2 to infinity 0.9772 minus, here only I'll just write it, 9772 minus 2 to infinity value. 2 to infinity is 0. Finally the answer is 0.12. So 95.56 is the value. So you can just write it as 95.44. Clear? This is the problem. Note down. So mean mu and standard deviation sigma are given. Just questions 2 they have asked x greater than or equal to 105 and x lies between 90 to 110. First let us consider z standard normal form. Both the sides minus mu by sigma. Carefully you observe both the curves. So this curve is 1 to infinity, directly can be taken as from 1 to infinity. Check page number 430, 1 to infinity value 0.1587. And the second question, minus 2 to plus 2. Again, if you observe area properties, plus or minus 2 region covered is 95% in a normal curve. But here we have to prove and show. So minus 2 to plus 2, shade the region. From minus 2 to infinity, just we have to remove 2 to infinity, blank space. Because as I mentioned once again, plus or minus z to positive infinity only we have all the tables. We don't have negative infinity side tables. Always we have towards positive infinity side tables. So area from minus 2 to infinity minus the empty region 2 to infinity. Remove that. So minus 2 to infinity value is 0.9772 and 2 to infinity value 0.0228. Just go through the tables. Final answer is 0.9544. So with this I am going to wind up this class. In the next video, few more 5-mark problems we are going to discuss. Clear? I hope my explanation is reaching your mind. Concept is very clear, right? Kindly go through the properties of normal distribution. Every class I will be saying this one. Properties are very, very essential to solve the normal distribution concept along with the tables, normal tables. Remember. Fine? So with this I am going to wind up my session. So let us meet in the next video. Stay home, stay safe. Thank you.